Thank you very much for attending this talk. I know that second talk is really interesting about those buffers, but I heard that there should be recordings. So I am also looking forward to see that second talk. And I will try to entertain you here about data lakehouses. And this is like very broad topic, so I spent quite a lot of time and quite a lot of discussions with my colleagues and other friends about how to actually focus this topic. I had opportunity to participate over my career on multiple projects of data warehousing and data lake, and lately also some sort of data lakehouse project. And therefore, I sort of like lived through all this history of this topic. This is what I want to show you. And since it is a bit difficult to find some interesting pictures, I generated something using Deep3 generator. So hopefully you will enjoy it too. So what is data lakehouse? Yeah, this is amazingly simple question, but it is also very difficult to answer it. And when I asked people, I got quite different answers. So some people and some articles say that if you use those modern formats like Apache Iceberg, Hoodie, and Delta Lake, then you have data lakehouse, because this is how they define it. Others say that you need to have object storage with structured and unstructured data. Here is like first confusion, because unstructured data are like videos, audios, texts. For many people, unstructured data are sort of like data not, enclosed in a relational database. So there are like different points of view. Other people see it as data pipelines. And I also had idea that actually data mesh and data lakehouses are merging together. And this is what we have like in the company, like all those local databases, data warehouses, data lakes, and this is like data lakehouse. Okay, fair enough. Some articles really enforce this idea. And other people say, oh, you need to have all this and data governance, because otherwise you will get data swamp. Okay, I can subscribe to this too. And we now have amazing articles and white books and whatever you can imagine about AI. So if you have all this and AI, only then you have real data lakehouse. So, okay, I decided that I will explain and explore how our Postgres actually fits into all these ideas, and therefore let's dive into it. So first, data formats. Here comes like first rule, I would say, from those projects which I participated on. And it says that we shall store only data which we really need and store them in an efficient way. I witnessed companies who actually spent a lot of money collecting data, and they being proud of having petabytes of data. And when you ask them what they will do with that data, they say, oh, we don't know yet, but we will find something. Well, what about the return of investment from all this? If you collect some data and store them, it costs money. So we also have those regulations which require clear data retention policies. And over those years, we actually discovered that many companies in long run just need only aggregated data. In many cases, raw data are deleted practically immediately after they are processed. So with this in mind, let's look at some ways how to effectively store it. So 20, 30 years ago, we had relational databases, and that was that nice era of those proprietary databases. And everything was stored mostly in row-oriented storage and processed through SQL. Then came era of online applications and online transactions and all this stuff, and new technologies required new formats. So we suddenly started to talk about processing JSON, Avro, ORC, Parquet format, and also unstructured data. And as I said, for some people, even these formats were sort of, semi-structured, although they all enforce some type of structure. They even have that structure embedded in its definition. But anyway, no matter how we look at it, Postgres is nicely equipped. We have JSONB implementation, very strong. I had actually a talk last year here about my project discovering JSONB and different indexes. And we have now also this Ferret DB and extension document DB, which implements actually sort of MongoDB inside Postgres. Amazing stuff. And we have those foreign data wrappers and also new extensions which aim to access directly these formats. I will talk about them in other slides. From all these formats, Parquet actually requires more attention because all those modern data formats like Iceberg, Hoodie, and Delta Lake are based actually internally on Parquet format. So Parquet format is a columnar storage format, and it contains a lot of metadata, which actually allow for a very efficient access just to those parts of data you really need. So you don't need to read like the whole file to get the data you need. And it is particularly visible if you have Parquet format linked in BigQuery, because on BigQuery you pay for amount of data you process. So on Parquet format, you can really save a lot of money. With Parquet format on BigQuery, you can save a lot of money because it can really read just those portions of data you need. And this columnar storage of Parquet is now building block of everything, all these new data formats. So first I have to mention Apache Avro, which is actually in-memory analytic framework which implements columnar storage, columnar data format into memory. And I will talk about it. And those three, Iceberg, Delta Lake, and Apache Hoodie, they are quite similar with some differences, but idea is very similar. So first about Apache Arrow, why I actually mention it here, because it's not exactly like storage, it's really memory. Because thing is, if you have really columnar data in your storage, you also want to process them efficiently in columnar way in memory. And this framework implements also the idea of zero copy reads, meaning you have that object one time in memory and you share it between the different processes. And there is this new interesting database, DuckDB. I will talk about it, although name sounds slightly like a joke, but it's actually sort of close relative with Postgres. But first, let's dive into these three formats. So first is Apache Iceberg. And as I said, all these formats are internally on that data layer based on that Parquet format. So if we look here, this is that data layer format. And here we have layer of different metadata files and log files. Why we need those log files and metadata files? Because as amazing for heavy reads as Parquet format is, it is really painful to update data in this format. So creators of these all three data formats decided to not even try to rewrite Parquet data, and they created this layer of metadata which actually store all those changes. Idea is that you store mainly immutable data, and if you, for whatever reason, like fixing bug or something, need to update some portions of data, they expect that you will update just small enough data to, still make this format work reasonably quickly. And those other two formats Delta Lake and Apache Hudi, they actually implement exactly the same idea. Here are those Parquet data files and log files, the same here in Delta Lake, and as I said, also here in Apache Iceberg. Difference is how data are stored and how you can find them. So here in Apache Iceberg, you have this central catalog. You ask that catalog for specific data, you get information where to find it, and then you go for that data. Here in Delta Lake and Hudi, it is more close to old Hive format. So you have here directories, like here is that example with directory sales. And inside a directory, you have all those Parquet data files and log files, which are actually connected with this particular data. So that Delta Lake and Apache Hudi, they are like more simple. Apache Iceberg is like more rich, and it also allows like rich partitioning and other stuff. But general idea is like very similar and depends on our use case which we want to use, which format we actually choose. This is something which currently is being implemented into Postgres using that DuckDB. There are two extensions currently being developed, which is PG Analytics, created by ParadeDB team, and this PG DuckDB, which is created by a team around DuckDB itself. Why they use another tool? Reason is that DuckDB is actually quite amazing in-memory analytical database, and I just wish they would choose different name, because if they would name it like super analytical database, then yes, we would love it. But DuckDB sounds, slightly like a joke and fits more into Disneyland than in our modern companies. But I love that tool. I have a talk about it. It was actually recorded in the beginning of January on that Postgres meetup for all, which is run by Crunchy Data. And here you can find a lot of stuff. So I can highly recommend you to check DuckDB, because I think there is a great potential if we take DuckDB as sort of a rich client for Postgres, then we can solve a lot of problems which otherwise could be like problematic for solving inside Postgres by using those standards foreign data wrappers mechanisms which we currently have. And this is the idea which these two extensions actually implement. PG Analytics is actually heading more towards, allowing access to all those cloud storages and those data lake formats. PG DuckDB wants to implement like the whole functionality of DuckDB, which, by my opinion, would be also very amazing, because it has like strong analytical functions. But anyway, no matter how we look at it, Postgres is on the trajectory to implement all this stuff, and I hope that it will be soon like production ready, and we can therefore use these data formats. So if we see data Lakehouse as something which is using these formats, Postgres is definitely almost ready for it. What about data pipelines? If we say that data Lakehouse is if we have data pipelines processing all those structured, semi-structured, unstructured data, how Postgres fits here? Yeah, Postgres fits here perfectly. The only thing is that there are many opinions about how that data Lakehouse should be structured. And as usual, many marketing articles are trying to sell you some solution, like you need to centralize, you need to have one source of truth. Yeah, theoretically, yes, this is true, and this idea saved a lot of companies in previous years. But for this heterogeneous environment, one size definitely does not fit all cases. And I want to show some examples to demonstrate it. Here are 3 projects on which I participated in some level, and all those 3 projects use heavily Postgres, and they used it in different ways, and they also in different ways process and store raw data. So let's look at first of it. This is telecommunication software for events from mobile network. Classical mobile network is all about sending different messages, different events, whatever you can imagine, in very different formats. And it's huge amount of data. Around year 2000, it was like dozens of gigabytes per minute. In these days, it's hundreds of gigabytes per minute and even terabytes per minute. This is all going behind the scene, and telecommunication company needs to have some statistics about all this data, all these events which are happening inside inside that network. So raw data are stored only for short time before they are processed, aggregated, and once they are aggregated, they are deleted. So this solution is like originally classical data warehouse, which was back at the beginning of 2000, created, of course, before Kafka. It was before Kafka became production ready, so they used some servers, and hardware in those days was quite slow and quite weak, so they had one central Postgres which used old extension PG proxy to distribute data on different machines, always like 5 minutes of data on one machine, switch to another machine with another 5 minutes, and so on. And once that portion of data was stored on that particular machine, heavy aggregations started, and aggregated data were shifted to that data warehouse, which was like much bigger, storing just aggregated results. In these days, they changed it, use microservices, use Kafka. They could even put all this stuff currently on one machine, because we now have completely different hardware. And they also now add some semi-structured data from those messages, because in some cases, a telecommunication company needs to see also details. So they are now turning this classical data warehouse solution into a mixture of warehouse and lakehouse. And as you can see, everything is nicely centralized. There is really one source of truth, although no raw data are stored. They are processed and deleted. So this was classical centralized solution, now mixture of this solution. This is a widget predicting sizes for online stores which sell clothing, and here they need to quickly predict size, calculate size from height, weight, gender, and age. And of course, they know from which country you are connecting, because there are differences, like typical Americans have different sizes than typical Chinese, of course. And therefore, they first process that widget data and go into Postgres data warehouse, where they have all those machine learning models, results from those machine learning models stored and give prediction. But to make this system work, they need to collect a lot of raw data from a lot of events from those websites and from widget. They put it into Kafka, and then load it into Postgres. There was like huge discussion a few years ago that they need to change that solution to remove Postgres, but actually it stayed here because it withstood like that probe in time. So it is still running Postgres, and data which are mostly relational are put on cloud storage. And here we have like main source of truth, which is BigQuery, which processes those relational data from those events, but also a lot of product exports from those shops. And you can imagine that if you have 100 different clients, you will see something like 100 or even more different formats. Because there is no standardization. You will get XML, you will get CSV, whatever you can imagine. And this everything must be processed. And as amazing as BigQuery is, it is also incredibly expensive if you process a lot of data. So this is why this architecture is mixture. They have like that data lakehouse, which now fits that idea of having a relational and semi-structured and whatever formats you can imagine. But they also do aggregations on BigQuery and put results into multiple different Postgres databases. Because they save a lot of money this way. And they use those Postgres warehouses and lakehouses for other stuff around it. So this is like mixture. And here is that third example, software for secure logins and financial transactions. If you have online banking or whatever software for online operations, in these days, just password is not enough. Because machine can be, actually attacked by a remote access, and someone can access that login from your machine. So in these days, these institutions require behavioral analysis. So this software actually collects a lot of data from devices, and those websites collects like how mouse is moving or what you do with your mobile phone and so on. They must quickly calculate behavioral profile and compare it with those profiles which have been already seen for that user, and say really in milliseconds if that operation is secure or not. It works amazingly well. Results are very good, but across the company they have very different use cases for raw data. So originally they were under that influence of, we need to centralize everything. So they ended up with huge several terabytes cloud disk which had 20,000 IOPS. They paid through nose for it. And they have seen that this solution is really not helping them. So they completely decentralize it. They have now only this central Kafka. And here, the raw data live only for hours. And there is some operational backup of raw data on cloud storage with expiration of few days. But otherwise, each department of the company takes its own data and processes them in different way and stores only this processed data. Because from some perspective, what happened 1 minute ago, if they did not react correctly, it's already history. And things which are older than few dozens of seconds are just taken for either reporting or for constructing those long-term behavioral profiles. So there is no central point of storing data because it did not work. It was expensive. It was really annoying. It was not fitting. So they decided for this solution, they have even more Postgres databases inside that solution. I just put those most important ones. So now we can really see that Postgres here is fulfilling very different expectations. And to be honest, in that second example with that widget, in these days, we could even, remove that BigQuery part and put Postgres back in there, and it would be much cheaper. It's just that in those days, when they decided to switch to BigQuery, it was still giving better results on hardware which was available back in those days. But in these days, they could even, remove BigQuery and do everything on Postgres. So we have these extensions, very powerful partitioning, PG Partman. We have Citus distributed Postgres with columnar format. This is like a very strong extension. We have also timescale DB. There is also this Hydra and Oriole DB projects, and Postgres and all this stuff. So I think Postgres is like best equipped from the currently available databases. At least this is how I see it, that it is the best. So there could be different opinions. So we looked at technical part. But as I said, many people say data lakehouse is also that stuff above it, data governance, and also AI. So let's look at this problematic of data governance. And since we are in Prague, I would like to demonstrate this learning on, our iconic character, good soldier Schweig, who said that discipline is essential. Without it, you would be climbing trees like monkeys. And I love this because, I see data governance as that discipline, around data. Because if we would not have this discipline, we will be really jumping like monkeys from one buzzword to another. And I witnessed this in my previous companies because it was always like, oh, it's a mess. We need something amazing, something new. And it was really like that jungle jumping, and it was not working because what we really needed was data governance, and it was quite painful learning. So when you look at data governance, you can find a lot of stuff, and usually all those articles are overly maximalistic and complex, and they, of course, manipulate you towards, just buy our solution, buy our services. It will solve all your problems. Yes, why not? If you have big company, you need a big solution, and then definitely you will pay some external company to implement it. But smaller companies, they can start with simple rules. Here, just for information, this is the source of all data governance knowledge on this planet. I would say dramatically. It is an international non-profit organization, data management body of knowledge, and they created this nice book. You can download it from different pages on internet. It's like really huge, like more than thousands of pages, and you can find really everything. But as I said, you do not need all this stuff. So here are some painfully gained learnings from those projects. So if you have bad data, you will get bad results, no matter how much you would want to, hide it from yourself. So garbage in, garbage out. If we process garbage, we cannot get anything good. So what we really need is some, at least rudimentary data quality. And to understand what is good, we need to define it. So we need at least basic data catalog and basic data definitions. What we actually learned is that documentation must be as close to code as possible. So, for example, comments on tables and columns, as old-fashioned as they may sound, they are actually absolutely close to data. Also, comments in source code. There are amazing comments in Postgres source code which are not documented anywhere else. So having some tools which will use all this stuff will solve a lot of manual work, additional manual work. And based on these data catalogs and data definitions, you must create data quality checks and some data profiling. But still, if there is no responsibility, if no one is the owner of data, no one will care, because it will be, oh, like we don't have time, we must, implement these new features, and we also don't have time, we must do those reports. No. We clearly need to define who are data producers, who are data consumers, who are data owners, and who is the guy in between those data stewards, which are actually responsible for, keeping data in shape. And without this, you will be chasing ghosts, because you will have data which you can only hope that they are good, but hope is not a strategy, as they say. And here is another learning: security and privacy. In these days, we have all these new requirements in law, like GDPR, CCPA, you know it, and they distinguish data security and data privacy. So security is defined as safeguarding data, and privacy is defined as safeguarding user identity. Because we store those personal identifiers, and with some personal identifiers, data privacy of users can be really compromised. So as much as companies hate it, this principle of least privilege and only for limited time is the best way how to implement it. When we were bought by American company, because I worked in one startup, very agile. They immediately implemented this as a first step. Everyone hated it, and after some time, we finally have seen that this is something which solved a lot of problems we had. But in that agile mindset, it was seen as limitation, and we want to have only a sky as a limit, of course. But when it comes to data security and privacy, then we must be very cautious, because those fees for security breaches and privacy breaches are quite huge. And if we look at Postgres regarding data governance, then this is true for all databases, not just for Postgres. That governance is usually something happening outside of database. Of course, we can enforce data quality using triggers or constraints, or we have this PGTAP extension for unity testing. But in many cases, we need to store data as they are and make them cleaner later in different steps of data pipeline. So it's more about really external tools like this DBT tool and Great Expectations library. And in these days, there is huge work on those frameworks for data catalog and data lineage. There are several of them. There is also this Parquet project for visualizing metadata. So hopefully, when these things settle more, we will also see some closer integration with Postgres, because I think exactly this data catalog and lineage would be some very interesting addition into Postgres. And of course, in these days, if you don't AI, you are doomed, because future is all about AI. AI is coming. And therefore, another learning is, do not believe every AI marketing hype. And there are many, marketing ebooks and articles over-promising AI capabilities. I spent a lot of time reading them, and since I also had several talks inside NetApp about AI, about prompt engineering, architecture of large language models, and all this stuff, also did a lot of experimenting with AI, and I use AI really daily. I have very good idea what it is good for. So Let's dive into it. What we must understand is that from the perspective of AI, there is no concept of correct or incorrect answer. Nothing like this exists inside large language model. There are just probabilities. So the answer is the most probable one you can get based on input and based on training data. And this is exactly that problem which should be emphasized because answers we get from AI, they sound nicely. They are so convincing, but just because it sounds plausible, it doesn't mean that it is true. And the biggest problem is about quality of training data. So if you have in your data warehouse, data lakehouse topics, which are very well documented and discussed many times, like invoicing, financial reports, physical warehouse management, or some taxi services or whatever, for which you can gather a lot of data, then you can expect that LLM will have exactly this data available. And therefore, it will work amazingly for those mainstream topics, and you will be happy with AI. But if you are some cutting-edge startup and you are developing something niche topic, then you can expect all sorts of most probable, but unfortunately hallucinated answers, simply because not enough data would be available. So AI will make very weird connections, very weird associations. Well, you can take it as inspiration. My daughter uses AI for creative writing, and she is quite successful, and I like what she creates using AI, but you must be careful when it comes to data. So there are some well-known and already named problems with AI, which are discussed in literature around AI and all those research papers. And you can see it when you try some really specific topic on different AIs, and also on those locally running open source AIs, especially those which has like a high degree of quantization. So all this stuff can happen there, and there is also this problem with incorrect input or input which is not complete. AI will also try to fill gaps in your input. I have the whole talk about it, showing how setting different roles for AI and also for myself influences the output very strongly. Because if you just ask AI, tell me something about this data, it will most likely presume that I am just average Joe, and it will tell me, oh, my dear average Joe, this is what I think about data. But if you say, dear AI, we are all top-level experts on data lakehouses, and we need to analyze this data, then AI will say, oh, this is nice to talk with another top-level expert, and this is my opinion. Those will be completely different answers. Also, based also on a system prompt, but still, these details matter a lot. And there have been already some promises around AI which stayed unfulfilled. Like 1.5 years ago, everyone was big expert on fine-tuning, and suddenly later, like half a year later, there were research papers saying, oh, if you try to fine-tune LLM in improper way, you can kill it. Okay, we learned that fine-tuning is not that simple as we thought originally. Then this retrieve augmented generation idea came. Huge boom around those vector databases. This is amazing solution. I love it, but it is solution for highly specific use cases like chatbots, help desks, FAQs, Q&As, meaning stuff where you can give that amount of additional knowledge you need, and it will simply do all that manual work around it for you. But if you want to analyze your highly specific data, then rec will not help because you would have to first, put all those examples and explanations into rec to get them back, which is not what we want. So here is now a huge hype around AI agents, so huge that even some vector databases seem to postpone their future development, and they are waiting. But what we need to understand is that all that amazing stuff which can be processed by AI agents will be at the end fed also again into large language model or into several language models, so we can expect the same behavior. Like on those mainstream topics, it will be amazing. It will work much better than one LLM. It will do a lot of analysis around it. So yeah, it will really improve usage of AI on typical use cases of data warehouses and data lakehouses, and many companies will be happy. But again, if you are cutting edge startup and you have very specific data, you will probably see the same situation again. So no matter how we look at it, Postgres is heading towards this edge very strongly, and there was this amazing talk like 2 talks ago about that new AIDB extension, which is created by EDB. I really loved it, and I am really looking forward to test it when they make it open source, because currently we have this PG vector or this improved extension PG vector scale. There is also PG AI from Timescale again, and we have some implementation of machine learning in Postgres. So this is definitely a huge step forward. And last year when I was on a conference in Switzerland, I had their lightning talk, if we can put AI into Postgres. Everyone said, yeah, it would be nice, but no, it doesn't work. But yesterday, actually, Gulchin told me that Oracle just did it. Oracle put AI into database. There aren't many details, but I presume that this is some open source model running like together with database, and you can access it from your database directly. And to be honest, some open source models are quite amazing. Previously, it was those were mainly Mistral models, but in these days we have DeepSeek. And it's like a huge boom suddenly, because that DeepSeek looks like performing much better than what was previously available on open source scene in previous months. So if Oracle did it, let's do it too, because technically speaking, it's not that big problem. I had some locally running rack applications, so it would be something similar. I am not the expert. I do not pretend to be expert. I always, learn from others, but it shouldn't be a big problem. So no matter how we look at data lakehouse and Postgres, let's look at this picture. I really love it. It's from blog called Postgres in Great Style, and they actually show how amazingly well is Postgres positioned in these days in different use cases. And I always remember, what Simon Rix said like 1 year ago here in Prague on Postgres European Conference. He said, maybe in 20 years, everything will be done inside Postgres. Yeah, well, we are heading towards it. We are fulfilling his idea. It was sort of his, dream. So everything could be done inside Postgres. This picture is a nice example of it. And here are also for use some sources which I also used. These books you can download for free from those pages. I really recommend them. And slides will be, of course, available online. So This is all what I wanted to tell you. I thank you very much that you stayed with me even that long. Thank you.
Hopefully, any questions?
Yeah, our colleague from India.
Thank you for the talk. You mentioned Hydra, and Hydra is something that has columnar tables, columnar data, and alongside your row-based or normal relational tables. So that is possible within same Postgres database. So do you think this format would be slightly better than having separate iceberg or separate Parquet format and separate relational data?
Yeah, I think we are definitely heading towards heterogeneous storage. For example, MS SQL Server also has this possibility to have row storage or columnar storage inside one database, and I think this is what we really need because for those heavy analytical queries, if you have like really already immutable data, then storing them in a columnar format for analytical usage is definitely an advantage, and we do not discuss it because it's like already discussed in many papers. So my hope is that in very near future we will have all these types of storages, and maybe implementation of that DuckDB engine closer to Postgres will help because they also have internal columnar storage. So hopefully these projects will continue. What I also like actually. Also on these new projects like OrioleDB, they also try this copy on write mechanism for checkpoints, which I also think would be like a really good addition to Postgres. Maybe configurable, okay, but creating a new copy of page on checkpoint will actually even further, at least from my experience, further minimize locking during checkpoints. So hopefully there will be huge progress in this area, and we will have heterogeneous storage, and really we could say using columnar or heap storage or whatever storage. I hope this answers your question. Depends on use case, because if you collect data, then storing them in row format is definitely quicker because you insert row and you insert another. So for data ingestion, row format is a huge advantage. But if you process then those data in further steps of data pipeline, then in some step you end up with data which you hope are immutable. And in this case, those immutable data should be definitely considered to be stored in columnar storage, because all those reporting software and whatever you are using it for will definitely profit, from this columnar storage. So it depends on which step in the company, the data will be processed. Yeah.
And any other questions? Okay, then I have a question. If you draw the pipelines, what's the default behavior if you receive a data that do not fit the description of the data, so they have to be discarded or stored for later processing as an invalid input which must not be lost?
Like you get data which cannot be processed by current data pipeline?
Yeah.
Yeah, well, as I learned, most companies currently try to avoid it because, I think there is this problem that at some moment when we get new data, like from that widget example, like a store sends us some new product catalog, which is in completely different format. Usual way was to do some, manual discovery process on it. But in these days, with AI, I sincerely hope that it will be able to give us a lot of information, not necessarily 100% true, but, I personally use AI for generating test use cases and also for some, benchmarking and this stuff. It gives me quickly what I need, and I also feed that result back into GitHub Copilot and tell him, look at the data and give me a code which will plot what is most important from that data. And I get like in 10 seconds Python code which is plotting what I need. I immediately can look at those graphs and see, yeah, this is interesting, this is not interesting, this is more interesting, you know. So I see like there, if we get some data which we don't know currently. In these days, probably it will be still like cooperation, human and AI, but in the near future, probably AI would be able to take a lot of these things and process them automatically. But we must be sure that we are not processing nonsense. So because AI does not need to do it properly. So we need to assess if it is done properly. So all these ideas that AI will do everything on its own, well, AI does not need to do it. We need AI to do it for us, to help us. But without our supervision, it can create nonsense and no one would care, and it will not work. Yeah. So this is how I would see it. I hope it answers at least partially.
Okay, thank you. Any other question? And thank you for the talk.
Yeah, thank you very much.